All right, let's look at the second half of this this worksheet, and we're looking at excuse me, empirical formulas, which is the lowest whole number ratio. So if it's like C4H8, that would be a 1 to 2. So let's look at question number 9 here. What is the empirical formula of a compound whose percent composition is 92.2% carbon and 7.8% hydrogen? Well, it says see question 8, table 1. And so we've got this and this. So here's our carbon, here's our hydrogen, and the molecular formula is C8H8. So we want the lowest whole number ratio. Well, you can see this 8 to 8 excuse me, is really 1 to 1. So it would be CH. Verify the empirical formula for hexene. See table 1. So if we flip this over, we see hexene is C6H12. So we can write this down. C6H12. Well, 6 divided by 6 is 1. And 12 divided by 6 is 2. So it would be CH2 would be the empirical formula. Make sure you read through the next section here, and we'll talk about this in class also. And so let's flip it on the back side here. So find the empirical formula for a compound that contains 82.4% nitrogen and 17.6% hydrogen. Well, let's just assume this is 100 grams. So nitrogen, we have 82.4, and we know the atomic weight or atomic mass of nitrogen is 14. So 82.4 divided by 14 is 5.9. Pretty darn close to 6. 5.9. And we're looking at hydrogen. It says it's 17.6% hydrogen. Okay. And we know the atomic mass of hydrogen is 1. So that is 17.6. Whenever you got a percent and they're talking about empirical formulas, assume it's out of 100 grams. And that makes life relatively easy there. So we would need to find the empirical formula. I'll take the lowest number. 5 divided by 5 is 1, or 5.9 divided by 5.9 is 1. And 17.6 divided by 5.9 is pretty close to 3. So that is a 1 to 3 ratio. So NH3. And so that would be the empirical formula. The next step from the empirical is let's see if we can figure out the molecular formula. So that's the next thing we're going to do here. So we've got the empirical formula for a certain compound is NO. And the molar mass of the compound is 60 grams per mole. All right, so so that's all well and good. So what is the molar mass of the empirical formula? Well, let's see what we got going on here. We know the molar mass is 60. Let's find the empirical. Nitrogen, we know, has an atomic mass of 14. Oxygen, we know, has an atomic mass of 16. And it's NO, so it's just one of each. So the atomic mass of the whole thing is going to be 30. Alright, so that makes some pretty good sense there. So what we need to do next is divide the molar mass of the compound given in the question by the molar mass of the empirical formula. This is what we found for the empirical formula. So we have 30 divided by 60. So at that point, we have 30 divided by 60 is 2. And again, if you look at this, and we just have NO, and we find the empirical formula, and then we get that from the periodic table. But it says we got 60 grams of this per mole. So 30 divided by 60, it must be a multiple of 2. Your answer to part B tells you how many empirical formulas are in the molecular formula. You should now be able to write the correct formula, which is N2O2. So you have to multiply the subscript, you have to multiply the number of nitrogens by 2, so that'd be N2, and the number of oxygens by 2, which would be O2. And it says verify that it is the correct one. Alright, so we got nitrogen, which we have 2, and we know its atomic mass is 14, so that's 28. Oxygen, we also have 2, we know the atomic mass is 16, so that's 32, and I'm going to run out of room here, so I'm going to bring this over here. 28, 32 is 60. So this value is the same as the value up here, so we know that the formula N2O2 is correct. Number 13a, what is the empirical formula of a compound whose percent composition by mass is 85.7% carbon and 14.3% hydrogen? Assume these, again, let's just assume these are our grams here. So we got carbon, so we have 85.7%, or we can assume it's grams out of 100, and we know the atomic mass of carbon is 12. So that's going to give us 7.1. Hydrogen, we have 14.3. And we know the atomic mass of hydrogen is 1. So that's going to give us 14.3. Well, you can see this is pretty close to 7.1 divided by 7.1 is 1. So we got 1 carbon. 14.3 divided by 7.1 is 2. So we know the hydrogen is going to be 2 parts of hydrogen. And again, this is the empirical formula, or the lowest whole number ratio. Well, if the compound has a molar mass of 56.8 grams per mole, what is the molecular formula? Alright, so we can also figure this out. So we know that if this is the empirical formula, and we can figure this out pretty easy, we're going to take the empirical and divide that into the molecular. So carbon, we have 1, the atomic mass is 12, so that equals 12. Hydrogen, we have 2, and we know the atomic mass is 1, so that's 2. So we know the empirical formula of CH2, we know that empirical formula has a mass of 14. Well, we've got a molar mass of 56. So what multiple of 56, or what multiple of 14 is 56? I think I said that in reverse. So I've got 56 divided by 14, and if my math is correct, that is going to come out to 4. Let's see if my math is right on here. So we got 56 divided by 14, and that is 4. So what this means is I need to take this empirical formula and multiply each of these subscripts by 4. So 4 times 1 is 4, and 4 times 2 is 8. So the correct formula would be C4H8. And again, once you have the empirical, all the molecular formula is going to be multiples of the empirical. So we're going to be doing some more of these problems. And again, quite often you just need to sit down and kind of work through these and wrap your head around these. And these, really, the math isn't hard. It's really kind of getting the crux of the problem of what's being asked in each of these. And let's see, I don't want that there. All right. So till next time, we'll see you later.